Coming up on this edition of The Climate Show, news that 2010 was indeed the hottest year, formerly 1998. Also our special guest, Gareth.
We've got Jason Box back with us for a repeat appearance. Jason's talking to us about the Arctic, Greenland and ice, wacky weather. It's a great interview coming up.
Stay tuned. It's all coming up on this edition of The Climate Show. This episode of The Climate Show is brought to you by hot-topic.co.nz, sideblogs.co.nz, skepticalscience.com, scoop.co.nz, idealog.co.nz and Kiwi FM.
Drop in the ocean. What good is a drop in the ocean?
Hello and welcome along to The Climate Show, episode number 25, recording 21st of March 2012. My name is Glenn Williams, recording here in Auckland City, and my co-host Gareth Ronalden joining us in North Canterbury, Waipara. How you doing, Gareth?
Very well, thanks, Glenn. Welcome to show 25.
Yeah. Indeed. So we've got a whole stack of news on the way, but we're also welcoming back a special guest to the show. Jason Box will be joining us. Refresh listeners and viewers on who Jason Box is.
Well, Jason's, first of all, he was one of the earlier guests that we had on the show, a big hit with our listeners and viewers, and he's one of the world's leading experts on Greenland. Every summer he goes up there and records data on Greenland's ice cap and how it's performing, and then compiles reports and so on. He's very well clued in to the state of the Arctic in general, as well as in Greenland. We're going to catch up with Jason shortly, go through a quick resume of what happened last year, what's happening at the moment, and what might be happening over the coming summer. We'll be talking to him to find out where he's going, what he's doing, and what we might learn from it all. And
John Cook is going to be back from Skeptical Science, and his topic today follows on very nicely from what Jason will be talking about.
Yeah, indeed. But since we're going to be talking a lot about the Arctic, then we thought we'd give John the opportunity to debunk the old myth that the Arctic sea, although the Arctic sea ice is declining, that somehow there is a slight growth in Antarctic ice. This somehow balances the other out. But John's got some interesting information to share with us on that. So you could look on this show as a sort of polar special, but with focusing on the Arctic.
Indeed, and we'll finish up with some solutions as well. And for anyone watching the video version of this, we've got some pretty pictures in the solutions version, so check that out. And just a reminder that it is available in both audio and video, so if you're listening to the audio and you want to check out the pictures, you can all find them up at theclimateshow.com, also at hot-topic.co.nz. That's where you'll find all the show notes to everything we'll be talking about as well. We make sure that we reference all the material, and you can go and learn a whole lot more from those notes as well. But let's get on into the news. First up, the Hadley Centre has published the updated global temperature series, including the Arctic for the first time, and well, I guess we'll be talking about this with Jason, but it shows 2010 was the hottest year.
Yeah, exactly. The Hadley Centre, which is the British sort of climate temperature collation centre, famously, it's the place where the emails were stolen from in the so-called ClimateGate affair. They've produced one of the three top kind of global series of temperature, and they're called HADCRUT, which is Hadley Centre sort of acronym for their temperature series. And until this week, the most up-to-date version was HADCRUT 3. Now, HADCRUT 3 showed slightly less warming than the other two main series, the one produced by the GISS, the NASA Goddard Institute for Space Studies, and also by the US's NOAA, the National Oceanic and Atmospheric. The HADCRUT 3 was the only series that showed 1998 as the warmest year, but it had one major drawback, which the Hadley Centre recognized, and that was that it didn't fully take account of the warming that was going on in the Arctic. In other words, it was underrepresenting the Arctic as a region in its global series. And that was because when they began compiling that series, they simply didn't have enough data from that part of the world. So what they've done is they've gone back and they've added in, I think the number's about 300 or 400 new sources of data from the Arctic, and incorporated that into their record. And so they're now, for the first time, beginning to take account of the full account that's been going on in the Arctic. And of course, the Arctic has been warming faster than almost any other part of the planet. So when you factor that back in, what that means is that recent years, and 2010 is the most recent really hot year, it's now effectively the hottest year in every major temperature series. So yeah, it's an interesting thing. It means that for climate skeptics who'd like to say there's been no warming since 2010 since 1998 or some year like that. Some of them go back even further. But anyway, it is that in order to make that claim, they've always had to just use the Hadley Center data. Now that Hadley has produced this shiny new polished version, they can no longer make that claim. Now, of course, that just means that they're going to whinge about people adjusting temperatures, and fiddling them, and it's all a big hoax and a con, because some people you can't you just can't persuade of the truth. But anyway, so it's an interesting story. It's kind of sets the scene for our conversation with Jason, and it does point out that the warming that we're seeing in the Arctic and have seen over the last decade is a really important part of the global picture, just because the ice is melting, but because of the impact it's having elsewhere around the planet.
Okay, all right, moving along. Over the northern hemisphere winter, we saw a lot of news reports about snowstorms and ice storms in the States, but the bigger picture has seen more of a heat wave, Gareth.
Yeah, well, there was that really cold outbreak over Europe earlier in the winter, and it really did get very, very cold, and there was a lot of snow falling in a few places. Most of the USA, however, has had a very mild winter. Stu Ostro, who's the Weather Channel meteorologist, described it as the year without a winter. But what we're seeing at the moment is a really extreme weather setup. Now, I follow this through Jeff Masters, and also Joe Rom at Climate Progress has done a very nice kind of summary post about what's been going on. And there's basically a weather setup with the jet stream, which has kind of wandered a long way out of position and created a very intense high-level ridge above the east, which has brought record-breaking warm air and warm temperatures to the Midwest and eastern USA. And we're seeing what Masters has been describing as, Ostro described as a tropical sky in his area in Atlanta. And Jeff Masters, who's the guy who established the Weather Underground, I'm going to read this out because it really amazed me. He said, "As I stepped out of my front door into the pre-dawn darkness from my home near Ann Arbor, Michigan yesterday morning, I braced myself for the cold shock of a mid-March morning. A warm, murky atmosphere with temperatures in the upper 50s, 30 degrees above normal, greeted me instead. Continuous flashes of heat lightning lit up the horizon as the atmosphere crackled with the energy of distant thunderstorms. Beware the Ides of March, the air seemed to be saying. I looked up at the hazy stars above me, flashing in and out of sight as lightning lit up the sky, and I thought, this is not the atmosphere I grew up with." Okay, so whether you think that's Shakespearean or kind of over the top, he's just describing a pretty remarkable situation that's going on. And from his blog today, he describes the numbers that are being seen in International Falls in Minnesota. Now, International Falls it's been called the icebox of the USA. In fact, I think they even trademarked the name, the nation's icebox, because it gets so cold in winter.
Is he really?
Now, yesterday,
I'm just going to say, is he really just describing what most people kind of feel, but they might not say that things have really changed since they were kids, and they don't really remember seasons like this.
Well, that's right. I mean, the thing about the weather that's happening in the US at the moment, certainly in the Midwest and in the eastern USA, is that you're seeing June or July weather in March, before the official end of winter. They're getting a prolonged spell of summer temperatures. Now, go back to International Falls, the nation's icebox. Yesterday, it hit 78 degrees Fahrenheit, which was 42 degrees the average, and the second hottest March temperature in the record. The record was set the day before at 79 degrees Fahrenheit. And the low overnight temperature between those two record days was 60 degrees Fahrenheit. And that equaled the previous hottest March day. So you're looking at these records being beaten by phenomenal margins. And what you're also getting, and this is what Masters describes as being spectacularly hard to do for a station with a century-long weather record, you're getting consecutive days breaking the old records. So to have one day set a new record, okay, that happens every now and again. Hot and cold records are set for individual stations on a fairly regular basis.
Yeah.
The hot ones outweigh the cold ones and have done for the last few decades in the US. But what you're getting in this heat wave is up to 9 days in a row. There's a good chance that International Falls is going to get past that. The first time the International Falls set a 9-day in a row record was in 1911, when it had actually only been recording bridges for 6 years.
Yeah.
And they're doing it now with 100 years worth of records. So this is absolutely phenomenal. And the same thing is happening in Chicago. Chicago area will hit 6 days in a row of record warm temperatures.
Yeah.
It's just absolutely staggering.
Is that quite significant? The image that we're seeing on screen, the website of myfoxchicago.com from the Fox network, is that rather significant that the network being has got a long history of being skeptical about climate change, is now reporting on these kinds of things?
Yeah, well, there are some things that are just undeniable. And, when you go outside in shorts when you should actually have a parka on, you just can't miss it. And, there are occasions when denying climate change is physically impossible. And with extreme weather, it is difficult to actually pick out events that are truly, undeniably down to global warming. But in this case, the heat wave that's happening in the USA at the moment and is likely to continue towards the end of the week is, I believe, undeniably made as bad as it is by the effects of global warming. And some of it may have something to do with what's been going on in the Arctic. We'll talk about that with Jason shortly. But the net effect is that it's got people like Obama, President Obama, saying he's worried by the weather, which is something of relief because he doesn't seem to have worried about it terribly much during his first term. Maybe it's a good thing. Maybe this sort of extreme weather, because I think this heat wave, in terms of extremes, are relatively benign. Hopefully it might just make a few people, it might be a teachable moment for politicians and people in the US.
Yeah. All right, well, that's what's happening now, but this article from ScienceDaily.com says that global sea level is likely to rise as much as 70 feet for future generations, Gareth.
It's an interesting story. A group of geologists, including some New Zealand scientists, looked at the late Pliocene, which is a period of about 2.7 million to 3.2 million years ago. And it's the last time that the carbon dioxide in the atmosphere was at the same sorts of level that we have today. Atmospheric temperatures, global atmospheric temperatures, were probably around about 2 degrees Celsius higher than they are now. And we're looking at a situation where they kind of got there a lot more slowly than our temperatures are increasing now. So what you're looking at there is a situation where the ice sheets that have had a chance to melt in response to the warming caused by the carbon dioxide. So you're looking at the kind of ultimate effect, if you like, when you look back at the late Pliocene. And what they find is that there's virtually all of the equivalent water that's in the Greenland ice sheet and the West Antarctic ice sheets has gone into the oceans and created sea levels probably somewhere between 12 to 22 meters or 40 to 70 feet higher than today. So what this is a lesson is that, what are we sitting on at the moment? About 395 parts per million of carbon dioxide.
Yeah.
If we stopped today and didn't do anything to try and reduce the amount of carbon dioxide in the atmosphere, then over a period, and we're talking a long term, we are talking probably hundreds, if not a few thousand years, eventually all of Greenland, all of the West Antarctic ice sheet, and reasonable parts of the East Antarctic will melt, will rise, and the outlines of the continents on our planet will change very significantly. Now, over the next 100 years, the ones that some of us listening to this show, or perhaps even taking part of it, might see at least some of, we're not going to see that sort of level of increase, simply because it's difficult for the ice sheets to physically melt that fast. But we've been looking at the estimates increasing as over the last 5 or 6 years from half a meter to people now talking about possibly 1 or 2 meters. The long-term picture is not pretty, and there's a message for us all, and that message is that if we really do want to preserve a planet for future generations that's at least in some way similar to the one we live on now, we've got to look at getting carbon dioxide levels in the atmosphere down. So the really important thing at the moment, obviously, is to get our emissions reduced. We know we can't do that overnight, so we're committed to having more than we've currently got in the atmosphere. But we're going to have to look, once we've managed to level off the amount of dioxide in the atmosphere, we're going to have to get very serious about taking carbon out of the atmosphere. Otherwise, we are definitely committing the world to an amount of sea level rise that we haven't seen in sort of 3 or 4 million years.
And what about the school of thought, though, that if mankind was to be around for a few million years, that they would see this sea level rise anyway? We're just providing it for a different generation than what would otherwise see it.
Well, no, not really. I mean, if we are fiddling with the atmospheric composition in the way that we have over the last few hundred years, possibly a little bit longer, then we will be more likely looking at an oncoming ice age and sea levels dropping. So it's not that we've kind of taken over the reins on the planet. The next ice age ain't going to happen while we've got these sorts of levels of carbon dioxide in the atmosphere. And I suppose if you want to look back from a period 5,000 years in the future, those people might well be cursing us if we've committed them to a vastly different planet. I mean, it's interesting. I did read a little item that was posted to Skeptical Science yesterday or overnight by a blogger called Kate at Climate Site, I think. John will correct us if I'm wrong. And she was talking about, looking back, what would we have said about the ancient Greeks if they had lumbered us with a huge quantity of sea level rise and a vastly different planet? If they had stolen the keys to paradise, that's my phrase, not Kate's, but it's an interesting perspective. And we do need, when we're planning, as I say, we've taken over the reins on this planet now. It's unavoidable. There are so many of us, and technologies that we've unleashed are doing so much to change the planet that we live on, that we do need to have a perspective that looks over the horizon and says what future generations are going to have to face if we don't clean up our mess. I mean, my motivation for getting involved in this was the thought of what my children and grandchildren might face in the future. That was Jim Hanson's motivation, was his young grandchildren, and the sorts of things we were committing them to. And taking that longer term view to me is the major reason for wanting to do something now, because the longer we delay, the worse it's going to be for those people in the future.
And the worse is going to be as well for people living right now, such as our Pacific neighbours in the South Pacific. And there's an article up at The Conversation about climate change and the future of Pacific Islanders.
Yes. The Pacific Island nations, I mean, I think you drew my attention, or rather it happened just after the last show, that a report in the New Zealand Herald, I think, that the island nation of Kiribati was looking at buying land in Fiji in order to move its people there in the event that their islands became uninhabitable. And the Pacific Islands have always recognized that they're in the kind of forefront of having to deal with sea level rise. What's happened is that there's been very little in kind of locally generated material on the impacts of climate change in the Pacific, certainly nothing terribly recent. And the Bureau of Meteorology and the CSIRO in Australia has put together a really major report, 530 pages, 2 volumes, Climate Change in the Pacific, Scientific Assessment and New Research. Now, this is obviously going to feed into fifth IPCC report, which will be due out in a couple of years. But this is the state of play in terms of what we know about what is likely to happen, what are the impacts going to be for those nations that are our neighbours and that simply don't have the kind of the economies or the infrastructure to be resilient in a way that perhaps we do in New Zealand or Australia or any of the major Northern Hemisphere countries. So I don't want to really talk about it in any great detail because obviously it's a 530-page report and I haven't really had time to read it.
Sure.
But for those who want to follow what's going on in the Pacific, and particularly in terms of the science of climate change and what we understand about what that means for the Pacific, then here's an excellent new report to refer to.
Indeed. Well, very shortly we're going to get on our special guest, Jason Box. Right now I do want to thank our media partners, including scoop.co.nz and cyblogs.co.nz, as well as idealog.co.nz. Thanks to all those guys for helping us get the show out there, posting the video and spreading the word about the climate show. All right, so time to bring on our special guest for today's show. Jason Box, back to the show. He's Associate Professor at the Department of Geography at the Bird Polar Research Center at Ohio State University, where it's late into the evening now. Jason, thanks for hanging around for us.
Yeah, it's good to be here.
You were on one of our earlier shows, one of our most popular guests. I believe there was a certain female blogger who described you as a bit of a hunk.
Oh yeah, that's good. Well,
what do you say to that?
My wife doesn't.
Yeah, exactly. Jealous. Where do we go from there?
Anyway, look, what we've been promising to do is to catch up with you about last year in Greenland, because you made some valiant efforts to collect photographs from the fun. We never really got a chance to catch up with you on that. And then you were very involved with putting together last year's Arctic report card, the section on Greenland. So we'd like to run through that with you, and then maybe take a look at some of the key issues that are beginning to emerge from the science that you're seeing, and of course what you've got planned for the coming year.
Yeah, there's really a lot to talk about. Being part of the Arctic Report Card organizing, we're seeing a growing body of evidence. The science is more complete than ever, of course, and there's quite a story to tell. As you've probably heard, the Arctic is thought of as an early warning for climate, and you're probably aware that climate change in the Arctic is amplified, whether that's warming or cooling. So it's a very sensitive system, and when we look, we see broad shifts in not just the physical climate, but in biological systems. And so the Arctic Report Card captures a very broad collection of science.
What,
Yeah, we've just been seeing in the Frozen Planet series, the BBC series with Attenborough, which I think is going out in the US at the moment. Most staggering pictures of that polar environment. It makes me very envious of people like you who get to go up there on a regular basis.
Well, I think what they show in on the nice programs like that is really like the best of, because a lot of times it's pretty uncomfortable and it's not fun being stuck in these airstrips, waiting for weather to clear. So yeah, I guess it may be a kind of a romantic view, but but it is also, of course, a kind of a visually stunning, and it's nice that many people around the world can be transported to that exotic, largely pristine environment with these new film productions. The BBC film production is just so good.
So tell us about your most recent visit up to that part of the world, and what did you see, and what were your experiences?
Well, we made 2 years of attempts to return to Petermann Glacier, and I actually did not participate in the final and successful trip to recover data from GPS, weather stations, and camera equipment. Sadly, the camera equipment didn't survive long enough to capture the loss of the 3.5 times Manhattan Island area of ice. However, we did produce a series of before-after photos from a number of different perspectives, and those, when we fade back and forth between them, produce a rather impressive effect. My colleague who did go kind of on my behalf said that he was gobsmacked by seeing it, even though he knew what to expect as he flew into this canyon. Having seen the satellite pictures, but he wasn't prepared for seeing it with his own eyes. I can see that you're scrolling through the before-after shots, and it's such a large space. It's 10 miles wide. Those cliffs on the far side or on either side are 3 Eiffel Towers high, and it's really literally an area larger than the Grand Canyon, and the pictures really tell the story about how it's transformed to a former ice shelf to open water.
But I guess some people would say, well, hang on, doesn't that happen every year? Doesn't the ice disappear and then it freezes over again?
It's true that the Petermann Glacier is advancing about 1.5 kilometers per year, and there are periodic breakoffs. It's not every year that you get a big breakoff. However, this breakaway produced a retreat of 14 kilometers, and searching all past satellite images, maps, and historical documentation, it is an unprecedented retreat at that glacier, and that's the same story at the other 200 marine terminating outlets in Greenland. In the recent decade of warming, there was nearly 100% consistent retreat at these many other glaciers. So Petermann is just kind of the biggest example. However, there practically every other glacier in Greenland is losing area, And the concern is that that's reducing flow resistance, and indeed the velocity of these outlets is being observed to increase. And so part of what the GRACE satellite is observing with increasing or accelerating loss of ice from Greenland is part of the story of the loss of ice area at the front of these glaciers is an important part of that, because it's less flow resistance. So the ice is just being forced out of these fjords, and it's encountering all this resistance. But with less ice at the front, it simply flows faster. And why these glaciers are retreating has a lot to do with warming ocean waters on the one hand, and on the other hand, increased surface melting. And so in a given year, the loss from Greenland due to glacier flow increases can be the largest single factor of loss. And in another warm year, the largest single loss can come from surface melting. So they're both competing with each other in year after year, and we're just seeing an accelerated loss that has a doubling time for Greenland, somewhere between 5 and 10 years.
So images like this, though, are obviously very powerful for science, but they're also very powerful for the media to use to communicate exactly what is going on, and you would expect images like this would be perhaps a tipping point for action. Were you happy with, or were you surprised by the action or inaction that these images produced?
These sets of pictures really were widely distributed, and so I think we were successful in sharing the story. As you say, the pictures really speak for themselves, and they do more than tell 1,000 words. They speak volumes to the reality of these changes, and so people get to see it for themselves, and that's the power of it, rather than hearing some articulated physics rhetoric. It just doesn't sink in with everyone, of course, because not everyone's spending their time educating themselves about the physics of climate, as important as that also is. Just seeing it with your own eyes. And I like this quote. You've probably heard that ice is nature's thermometer, and ice reacts to climate. It's a very useful indicator of climate. When a glacier retreats, we know that something's changed about climate, and ice has no political agenda.
Yeah, absolutely. So, okay, let's go back to the Arctic report card then, and look at some of the highlights. Now, this was produced at the end of last year, wasn't it?
Right. It's really kind of in constant development, and there are these annual, after an external review process, the report goes out live. We have a press release, and it was interesting this year as reporters were like, yeah, well, a lot of the same reporters from the previous year, and they're like, okay, well, what's different this year? It's not always newsworthy if you just say that the cryosphere is continuing to melt. Well, there were newsworthy items out of this most recent report that I can list off. I wrote them down here on paper. It's more than a page of just kind of bullet items, but they tell a coherent story. It's of a profound system shift.
Absolutely. Now, one of the key things that you've put in your list, and I'll put that list of bullet points up in the show notes so that everybody will have a chance to run through them all, and obviously we'll link back to the Arctic report card as well. But you're talking about a kind of regime shift, and some of the ways that is impacting the weather across the Northern Hemisphere. Do you want to expand on that a little for us?
Right. linked to the significant decline of Arctic sea ice. This is producing this kind of fundamental shift in the energy exchanges between the ocean and the atmosphere, because of course when the ocean is capped with sea ice, it reflects a lot of sunlight. Not only that, there are exchanges of heat that are wind driven, and again, when the sea ice is not there, the wind is able to mix the waters, and the heat exchange. So then in the autumn time, when freeze up is happening again, there's still a heat release to the atmosphere from this ocean that has been more exposed to sunlight during the summer months when there's 24-hour sunlight. So open water in the Arctic in summer, it means that it's absorbing 24 hours of sunlight and is really charging up with heat. So then once we go into the cold season again, it's of course freezing up later, but also releasing some of that heat to the atmosphere. The Arctic atmosphere is staying warmer, and so when we compare Arctic temperatures to the mid-latitudes and the lower latitudes, that the pole to mid-latitudes temperature difference is less than it used to be. The Arctic was colder in the past, and that temperature differential is what drives a vigorous atmospheric circulation. When the temperature differential drops, what's been documented in a very recent paper by Jennifer Francis at Rutgers is a slowdown of the Rossby wave circulation, the jet stream slowing down because there's less of a temperature differential from equator to pole. The Rossby wave has also amplified more, and that is exchanging more heat from the lower latitudes to the Arctic, and in some areas bringing abnormal amounts of cold. This past winter, it was northwestern Europe was getting a lot of this Arctic air, whereas another part of the wave, just further upstream in the wave, eastern North America had a record. Is still experiencing a record-setting warm winter. So the Arctic is influencing this weird weather that we're experiencing, where most people are living, in the northern hemisphere in the mid-latitudes. We're having, extremes in both hot and cold. Just depends on your longitude, really, and the placement of this Rossby wave. The wave has become more stationary, and that's producing more persistent climate or weather, really more persistent weather. So if it's warm weather, it's persistent warm weather, and we're seeing that right now in here where I am in the Midwest in the North America. It's just been like summer. We've gone from winter straight into summer, and we're setting day after day consecutive temperature records, like the sixth consecutive temperature record in Chicago just today, and this is a result of Arctic climate change. We're feeling that hemispheric change because of this fundamental change in Arctic sea ice and land snow cover. So that's really the kind of the big story about what the Arctic climate or Arctic report card called a shift in the Arctic system that has actually been persistent since 2007.
Yeah, it's fascinating. If we go back to that record-setting year for the sea ice minimum in 2007, people began to speculate at that point that it would have some sort of impact on Northern Hemisphere, particularly winter weather, simply because the refreezing of the ice was going to shove such a huge amount of heat in the atmosphere that it had to have some kind of impact. And then that was followed by a couple of years of very cold winters in the eastern US and also in Europe. And I think just in the last few months, there have been 3 or 4 papers. The one you've referred to is interesting because I think it's just come out in the last week. But there have been 3 or 4 other papers that have found various mechanisms linking different weather patterns to different parts of the way that the ice is behaving in the Arctic. I think there was a paper done out of Potsdam, which actually came out in the middle of the European cold spell, finding that the anomalous low ice in the Barents and Kara Seas, which is north of Norway and the Western Russia, was actually pinning the weather in a way that increased the likelihood of getting exactly the sort of cold outburst that brought record cold to Europe in February. So I think it's absolutely fascinating. I mean, obviously there is a sort of paradox that this dramatic warming in the far north is actually producing, in many cases, cooling further south, which makes it harder for the message to get out that, you know, this is we've brought this on ourselves.
Yeah, I think that now that it's been 5 years since this apparent shift in Arctic climate, that now finally the science is developing a coherent picture where we can link. I think this most recent paper by Francis, just makes a lot of sense that the jet stream is propagating more slowly, so that this wave train is moving more slowly. That's producing more persistent weather, and it's more amplified, and that's allowing areas of abnormal warm or cold, or abnormal moisture or dryness to more slowly make their way around the northern hemisphere.
So for video viewers, what are we seeing on screen at the moment?
Well, that's from the Francis paper, I think, and it shows seasonal geopotential thickness anomalies, like atmospheric thickness anomalies, and you can actually trace a kind of a wave pattern around those. They're really not that easy to interpret of graphics, but the jet stream follows kind of areas of equal color there, and I think the upper left one illustrates the winter situation, and you see a more amplified wave pattern. It should be, or a more simple pattern. Like the southern oceans, there's more of a zonal flow around Antarctica, because the continents in the northern hemisphere, there's more of a contrast between oceans and then land, and Greenland actually stirs up the northern hemisphere circulation and also anchors a wave train in a semi-persistent way. But there's more so-called meridional exchange or north-south exchange of heat in the Arctic because of these strong land-sea contrasts, and so there's a tremendous amount of heat that normally goes up the North Atlantic, so this north-south exchange is actually more amplified, despite the fact that there's less of an equator to pole temperature difference and a stagnation of this wave train, which normally it actually propagates westward, the wave train, but so this is atmospheric dynamics, and it's not a simple picture, and so for the public to interpret weird weather is very difficult, but I think if they have a decent explanation of the jet stream, it's not too complicated to follow.
Absolutely, and it's interesting you refer to the southern hemisphere there, because the intensification of the westerlies, which is the zonal flow that you were talking about, was one of the more robust predictions of climate models, and was one of the first things that was actually observed in the sort of numbers from the Southern Ocean, was that we were actually seeing this intensification of the westerlies, and of course that's had the effect of kind of bottling the cold up in Antarctica in a way that you don't get in the Northern Hemisphere.
Yeah, they call Antarctica. It's given that name for a reason. It's the anti-Arctic. It's quite literally the opposite. That's why it's called Antarctic. It's the antithesis of the Arctic. You have a continent centered at the South Pole, whereas in the Arctic you have an ocean centered at the North Pole. And so it's a very different climate regime in the South. I spend most of my time thinking about the Arctic. I think really Antarctica is in a lot of ways more complex, and there are not as dense of an observational network there on the ground. So Antarctica, and it's also a much larger ice sheet there. It's I think a more difficult problem.
One thing we keep on hearing about with regards to the Arctic, though, is this permafrost, and the fear that the permafrost is going to release methane as it thaws. So what is the situation with permafrost at the moment? Are we seeing an increase in temperature?
Right. The Arctic report card is careful to say, that they find no strong evidence of a change in the methane budget at the surface or methane exchanges. However, there have been some, reports coming from Russian investigators and others about changes in the methane or the surface carbon exchanges. I think it's clear that more observations are needed for that picture to emerge more coherently. Meanwhile, sufficient observations show a greening of the tundra because there's a longer growing season. Basically, there's a shorter snow cover duration season over much of the the Arctic tundra. In some areas, the tundra is getting more wet. In others, it's getting more dry. In West Greenland, for example, the surface albedo or reflectivity of the tundra is going up strongly, and something else that's catching our attention is increases in tundra wildfire, which is a normal occurrence. Occasionally, you actually have lightning strikes setting fire to tundra, and you have wildfires just like elsewhere on the planet. However, the observational records indicate that the frequency of tundra fire is on the increase. And that's not a surprise, really, given the fact that the Arctic has warmed so much faster than elsewhere. And so these tundra fires are going on, and there's really not many people out there to observe them. But they exert an important positive feedback by releasing a lot of black carbon particles, which drift around in the atmosphere, and being dark particles, or when they land, for example, on the Greenland ice sheet, they would contribute to a lowering in the albedo of Greenland and an amplified melting. Or these particles anywhere on the surface are just going to absorb more heat because they're darker. So that's an important feedback with the tundra that we should be aware of and deserves more study.
I know there were some remarkable images on the NASA MODIS satellite image website last Northern Hemisphere summer, of really immense fires going on in Alaska and northern Canada, and then across the straits in sort of eastern Siberia. There was a huge amount of smoke in the air.
Yeah, I'd like to see some of those images. I haven't spent a lot of time looking at tundra fire, but I think it may be one of the most urgent matters to understand. And with regard to the tundra, the methane that's stored there, I've spoken with some of the scientists that are studying this problem, and there's surprisingly a small number of observing sites installed around the Arctic to even just measure the carbon exchanges. We see some fairly sensationalized, stories about people, being able to light fires from, methane trapped under lake ice, and certainly to some extent that's natural, but it's also quite clear that as permafrost warms, the active layer can get deeper. It's elementary, really, and we just don't know it's not a clear picture because of lacking observations, really, that is the Arctic, becoming a source of methane and carbon from activated, more by microbiological activity in the tundra. Are these the images?
Well, I'm seeing this is from 2009, forest fires over the interior of Alaska. So I'm not sure if they're linked to what we were just talking about, but.
Yeah, there is actually MODIS produce or rather NASA produce a daily Arctic mosaic, which you can access at the MODIS site, and it basically is a mosaic built up from satellite passes over the whole of the Arctic region. And there were spells during the summer when you looked down on the world from the top, and you could just see great swathes of smoke over particularly eastern Siberia. It's actually what I used to look at it on an almost daily basis, because apart from anything else, it's very staggeringly beautiful images, particularly the sort of cloud streaks that you get as the cold air pours over the edge of the ice. I think Glenn's picked up on one showing the Bering Sea at the moment. Oh no, that's Greenland. Yeah. I find them absolutely beautiful images to look at. So the mosaic is definitely one to go for. Jason, so moving on. I'm aware that we're using up both your time and possibly also our viewers and listeners' patience, but this is a fascinating conversation we're having. So 2012, you're obviously off to Greenland again. You've got a full observing season planned. What are you up to, and what are your fears for the year?
Our plans for this year are exciting. We just keep building on past work, and this year we're repeating a study we did in 2008, but we're adding to it, and that is to observe a single marine terminating glacier in West Greenland. It happens to be the second most productive West Greenland glacier in terms of annual ice production, about 25 gigatons of ice coming out of this. It's moving forward at about 15 meters a day, and so we're fully instrumenting this glacier, or planning to. GPS on the glacier at a number of positions that's running continuously, and that's logging the speed, which is not constant in time. With tide gauges, we've already observed that tide produces a flow speed variation, as does surface meltwater intensity. So there's a weather station as part of the observational suite. Time-lapse camera documents when calving events occur, and seismic sensors on both sides of the glaciers would record the ice quakes. Hydrophones in the water can listen also for signals coming from fracturing, and tide gauges situated around the fjord register the timing of calving tsunamis. Meanwhile, a sailboat is making repeat multi-beam submarine swath images of the glacier front as it's moving forward. So it would make a pass, and then a day or 12 hours later repeat that survey and be able to image submarine melting, because each day there's about 10 meters of vertical ice melt going backwards, as this thing's moving forward. And so we can map the submarine melt rates, ocean current measurements, temperature, salinity profiling, So on and on. The goal, the idea is to develop a systems perspective of this glacier, and rather than just making a single type of measurement, like just sticking a GPS or a weather station, we try to observe a system, and so.
Just give us an idea where this glacier is, Jason, because when I'm
Yeah,
looking down from the sky on the mosaic, I'd like to know which dot is you.
Yeah, it's about halfway up West Greenland, and there's this very wide or long peninsula on halfway up West Greenland. It's called Nuussuaq, the Great Peninsula. This glacier is nested right at the northern side of that Great Peninsula, and it's a major outlet glacier. It also has fair weather because the peninsula blocks the marine weather coming in from the south. So it's actually a beautiful place to be in the summertime. And my daughter and wife are going to join me up there. And part of the motivation, quite frankly, is to escape the summer heat. It gets insufferably hot here in the Midwest in the summertime. It's like 35 Celsius.
Or in wintertime, apparently.
Yeah.
Yeah, I mean, it's surprising, the weather today. I was just in T-shirt and shorts, and it's still winter officially. But so we're actually escaping the summer heat. I just can't take anything warmer than about 17 Celsius, or 20, or let alone 30 Celsius.
Now we know why you work in the Arctic.
Yeah, well, it's a nice place to be in the summer. Really, it's not that cold in the summertime as long as you stay out of the water.
Your daughter is going to have to learn to be a very tough little swimmer.
Well, yeah, I hope that she, has a good experience, and that, that she grows from that experience. She's only 5 months old, or she'll be 6-7 months. I'm not sure, how that'll, help her develop, but we'll be safe with her.
Just finally, I mean, a lot of the stuff that you were just describing about the future plans, it sounds quite expensive. Are you seeing an increase in funding at the moment? Are people more worried about what's happening in the Arctic? So is there more money flowing towards research?
Well, when we use a sailboat as a platform, and this is a personally owned sailboat from a Welsh colleague, friend of mine, the costs aren't that great. He's just dedicating his own sailboat and borrowing a lot of equipment to put on it. We're deploying. So I just booked a helicopter charter today, and that's pretty expensive. I'm spending about $15,000 US on this charter. However, we're going to deploy like 10 sensors. Because fortunately, a lot of the time-lapse cameras weigh 20 pounds, the seismometer is 20 pounds. The GPS is really not that bad, so I think we're getting a lot out of this campaign. We also partner with locals, and we're not paying for accommodations. And then the U.S. National Science Foundation has got some support of this. And so we build upon an existing infrastructure so it's really not as it's not as expensive as trying to fly to Petermann Glacier. Now that is expensive,
yeah,
because there's no airports. You actually have to fly, fuel out, come back, refuel, fly out, refuel at your fuel depot, then go out to your site, come back, refuel, and you spend a tremendous amount just trying to put enough fuel out there. What about
so expensive. What about insurance for you guys? Do you get insured by normal insurers, or do you have to do something special?
Well, fortunately, we have insurance through our university, or I do, and I remember, trying to explain to my home insurance agents, because I have a life insurance policy, and she asked me what I do for a living, and and I really, tried to honestly explain. Walking on glaciers and so on. She just didn't seem to worthy to appreciate, some of the hazards. But we actually, based on the, when the risks are high, as they often are, we really we hedge our risks. At every step of the way to manage risk in a way that none of these are suicide missions. Like
So
we're all,
are the
safety, of
days
course, has to be.
are the days of abseiling into Moulin days over?
Well, I am more careful now with this daughter, and the abrupt climate change that we are witnessing. It makes it seem more important when I think about future generations, and so I think it's an important service that you're doing by sharing this story with a broader audience, and getting the story out, because as you know, it's become politicized because of large economic forces that are threatened by the reality of environmental changes. And it's important for independent media like this to tell the truth of what's happening.
Yeah, absolutely. Absolutely.
Well,
look, you're gonna be blogging from Greenland over the summer?
Yeah, I'll try. I don't produce a lot of entries on my blog. Sometimes I worry about that, but yeah, I will. And Twitter's nice because it's micro blogging. It doesn't take that long to come up with one of those, and so I'll be tweeting.
Okay, well, look, try and tweet us a picture for once a fortnight, and we'll make sure we stick it up on the Climate Show.
All right. Yeah. Well, thanks a lot.
Jason, many, many thanks for taking the time to see us, and I'm glad we didn't see your shorts.
That's right. Yeah, I'm relaxing here at home, and I'll be off to bed soon now. So good talking to you guys.
Great. Thanks very much, Jason.
Thanks,
Cheers
Jason.
for coming back on. See ya.
Bye-bye.
All right, great as always to have Jason Box on, but we're on to Mr. John Cook now, and of course Jason was just talking ice, so that's why John is also going to talk ice, and he joins us today from skepticalscience.com. John Cook, welcome back.
Hey Glenn, hey Gareth.
Hi, how are you doing, John? Very appropriate that we're going to talk about the Antarctic, since we've just spent most of the rest of the show talking about the Arctic. So what have you got for us?
Well, I just thought I'd look at two myths about Antarctic sea ice. And the first one is a myth that I think we might have even mentioned in a previous show. I think Moncton used to use this, saying that in Antarctica, the sea ice has actually been increasing over the last few decades. So he's saying that the Antarctic sea ice loss or gain is balanced by what's happening in the Arctic, which is losing ice, and overall it all balances out. But that's just untrue. Like when you look at what the actual evidence says, what the measurements say, what we see is Arctic sea ice has been falling at an accelerating rate, while Antarctic sea ice has only just slightly been increasing. So when you look at the overall result, globally, sea ice is still falling. So we got a nice little picture there that Glenn, hopefully you can bring up. And this is an animated graph that Dana created at Skeptical Science, which just compares what's happening with the Arctic. So let's see, here we have the Antarctic, which is slightly increasing. And then we see the Arctic sea ice is decreasing at a strong rate and getting faster. And the overall result is that globally, sea ice is falling.
Does this take into account, other glaciers around the world at all?
No, actually, that's a good point. See, what we're talking about here is just sea ice. So there's a big difference between land ice and sea ice. And often people get the two mixed up with Antarctica too. They say, hey, isn't Antarctica gaining ice? We know that overall, Antarctica is losing land ice at an accelerating rate, while the sea ice around Antarctica has been slightly increasing. So it's important to distinguish between the two.
Big question though, why is the Antarctic sea ice increasing?
Yeah, that's a really good question. And whenever I've read skeptic blogs talking about this, they just assume that it must be because it's cooling around Antarctica, and if it's cooling, that must disprove global warming. But in actuality, when you look at sea surface temperatures around the Southern Ocean, where the sea ice forms, it's actually been warming around Antarctica, around the Southern Ocean. And in fact, it's been warming faster than the rest of the world's oceans. So this is a big, it has been a bit of a scientific mystery, why sea ice has been increasing while it's actually been warming in that region. So there was one paper that came out in 2009 by Turner, which looked at ozone depletion, the fact that there was the growing ozone hole over the South Pole, and looked at how that changed atmospheric conditions, and it implied that the ozone hole might be causing the increasing sea ice. That's been the prevalent theory for the last couple of years. But in December, when I was in Canada, I visited the University of Victoria, and I was talking to John Fife, who's a climate scientist who's done modelling in this. And he said he just had a paper published that looked at that exact question, going into more detailed modelling on how ozone depletion over Antarctica should affect the sea ice. And what they found was, once they did the more detailed modelling, they found that the ozone depletion should actually cause a decrease in sea ice, have an actual opposite effect to what was being observed. So they basically ruled out the ozone hole as the cause of the increasing sea ice.
Okay.
So that was a very I was a bit dismayed during that lunch, because I had this model in my head of what was happening with Antarctic sea ice, what was explaining it, and suddenly that my understanding was had been ripped away, and I was left with this gaping hole. And so I said to him, okay, well, what is causing the gain in Antarctic sea ice? And his answer was basically, we still don't really know. So, which was quite frustrating.
I know there have been, there's been at least one paper suggesting that increased snowfall, because, a warmer atmosphere, warmer ocean means more water vapor available to precipitate out, that this might help to create more sea ice. But as you say, there doesn't seem to be much of a consensus about this yet.
No, it's still an area of, it's an open question, basically. And I emailed John Fife about it yesterday, just to see maybe over the last 3 months there's been a development or the understanding has increased. And he said pretty much the situation is the same. And I brought up those issues of increased snowfall, increased wind, which changes evaporation and changes in circulation. And he said that all those factors were included in their model. And their model predicted that they should be showing a decreasing Antarctic sea ice. And he brought up an interesting point. He said that currently what the models are showing is in the Arctic, they're underestimating the decrease in sea ice, and in the Antarctic, they're overestimating it. So you're kind of seeing reality is showing the opposite effect in the poles. And so one possibility, this is speculation, is it could be a case of internal variability, like there's a bipolar seesaw effect where you have like opposite effects in the northern and the southern hemisphere. And one paper I looked at suggested that there was a connection between Antarctica and the Arctic through the atmosphere, through the stratosphere. There's like a connection there. And so, yeah, it's the kind of thing that I think will unfold over the next few years, and it'll be interesting to see what they'll find out.
But essentially, the message that we need to take away from this session, though, is that sure, Arctic decreasing, Antarctic increasing slightly, but overall a decrease in sea ice.
Yeah, the two take-homes are overall globally sea ice is falling, but also Antarctic sea ice is increasing despite the fact that it's warming in the Southern Ocean.
There are a number of, I mean, when we were talking to Jason, he was talking about the Antarctic being the antithesis of the Arctic, the opposite. By being, instead of being an ocean at the pole, you've got this cold, high, almost desert continent stuck at the south. And of course, there are big differences in the sea ice regimes as well, because in the Arctic, basically, well, at least until relatively recently, it was only the fringes of the ice that melted. The main core of the ice around the North Pole, sea ice, stayed there all year. Whereas in the Antarctic, most of it melts every year. There's a chunk that doesn't, but you get a much bigger amplitude, a much bigger kind of loss and refreeze up in the Antarctic than you used to get in the Arctic.
Yeah, and you also have the Antarctic Peninsula, which is this big like jut of land sticking out, interrupting the Southern Ocean, and that causes all these circulation issues as well. And so, because the warming is strongest around West Antarctica and around the peninsula, sea ice actually is falling in that part of the Southern Ocean, but it's increasing around the other part of around East Antarctica. So yeah, I guess it's almost comparing apples and oranges. What's happening in the Arctic, where it's just open ocean, compared to this, the land with the peninsula in Antarctica. So yeah, it's complicated basically.
So basically, if you're using a global sea ice figure, what you're doing is putting together two things that are out of phase because they're seasonally 6 months out of sequence, where the conditions are completely different, that are showing opposite signs of change, and fundamentally putting the two together tells us nothing about either, or indeed anything at all about global warming.
Well, not exactly. It's a bit like when I read Mike Mann's Hockey Stick Wars book, one of the quotes that jumped out at me from his book was when he first published the Hockey Stick paper in 89, was it? Or 99?
98.
Yeah, 98. So what they did was basically looking at regional climate change, and the interesting parts of the paper scientifically were just how the different regions warmed and cooled throughout the past. Yeah. But then what they did was they just took the average averaged out all the different regions to create a hemisphere average, and that basically wiped out all the interesting information just to get the total average climate change over the northern hemisphere. And scientifically, that was less interesting, but it also told, because it removed all that regional information, but it still told the story of what was happening over the whole northern hemisphere. And obviously, that was the graph that everyone got excited about, because it showed that the climate change now is a lot more dramatic than what's happened over the last 1,000 years. Yeah. And I guess with global sea ice, what it's telling us is that, well, we're losing all that information about what's happening in the Arctic and the Antarctic, but we're seeing that globally our planet is losing sea ice.
Yeah, and it's interesting. It's a good point you make, John, because going forward, we've got model projections that are based on kind of multi-model means for global climate, and they're not telling us a very great deal about what could happen or what might happen on a regional basis. And of course, none of us live in a global climate. We all live in a local microclimate, which is part of a regional climate. And so getting some kind of handle on what the regional changes will be as the climate evolves into a warmer state is a really tough challenge for climate modeling, and it's going to be, the difficult question for modeling to answer over the next decade or two.
Yeah, I guess that's what the models are. Just the resolution is getting higher as the computer power increases, and they're also getting better at modeling regional changes, but that's really the final frontier for climate models is working out all the specifics of regional areas. Yeah. There was there was an interesting talk Ben Santa gave about climate models, and there was this one point where there was a gasp from the audience when we talked about they had like 18 different models from all the different teams around the world, and they were comparing the performance of each one. And then what they found, the best performer was when they just averaged all 18 models as a single average of every climate model in the world. And that was the best performer out of all 18. And I guess it was just a wisdom of crowds kind of effect.
Interesting. So yes, the climate models have their own crowd wisdom in there. Yeah. Something to think about.
All right. Well, I take away that sea ice is decreasing. That's my takeaway message for the day. Thank you very much, John.
Hang on.
Oh, we got a short link, do we?
Have we got a short link?
Oh, I forgot to give you one.
Oh no, I don't get to do my Moncton voice.
Well, I think if you hang on, let me just make sure that this link works. if you go to sks.to/ I do a terrible accent, Antarctica, then that should get you all the latest information. My computer's frozen, so it's not working. Antarctica.
Yes, there we go.
There we go. So that's http://sks.to/Antarctica.
Very good.
Thank you. John, masterful as usual. Thank you very much for that. And we'll be back to you in a couple of weeks. And I've got no idea what we're going to talk about. Have you got anything that you might like to throw into the mix?
Maybe headcrab, although that'll be old news by 2 weeks' time.
Yeah, well, we did have a chat about it at the beginning of the show, but I wouldn't mind going into it in more detail.
Well, who knows what will happen over the next 2 weeks?
Absolutely, they may get snow in Columbus, Ohio, because Jason was in shirt and shorts when he was talking to us. So.
And just a reminder, of course, if you've got any questions or any comments on anything we talk about on today's show, feel free to make a comment in the section down the bottom underneath all the show notes at theclimateshow.com or hot-topic.co.nz. Some people make comments in the YouTube video clip there as well, so you can do that, or facebook.com/The Climate Show, or there's twitter.com/The Climate Show as well. So plenty of places to take
We're
part.
Everywhere. We're absolutely everywhere.
All over the show. Let's go now to the next section, that is the solutions. So looking forward to perhaps a lower carbon future. And the first story here comes from the Stuff website, where Business Day was covering the news that Well Networks Limited in New Zealand is investigating the economic liability of solar power stations after more than a year of evaluating photovoltaic cells at its Hamilton offices. Of course, we've talked about this before, about photovoltaic. The technology is the same as that used in solar-powered calculators, which turn sunlight into electricity. The chief executive there of the electricity infrastructure provider, Well Networks, they said they had researched similar overseas solar power schemes and was looking at the feasibility of replicating them in the Waikato. So this is large-scale stuff, and finally being adopted here in New Zealand.
It's very interesting, and the key to it is that the cost per watt of solar cell, so the amount of cell that you need to generate a watt of electricity, has fallen by about 80% over the last year. And this particular article quotes it as being about New Zealand dollars 125 per watt. So that is a very considerable fall in cost, and it's come about because basically in China they invested an awful lot of money in large factories to make solar photovoltaic cells, and it's become a bit like the chip industry, where people, or the memory industry, where people would invest in capacity to make a particular process size. They'd produce it, they'd make money, and then everybody else would do it. The collapse would price would collapse, and then bang, you'd move to another process size, price would go up. And so this whole cycle is beginning to happen in the solar photovoltaic area, because the volumes that people want to buy have gone up because of the investment in solar photovoltaic, particularly in Japan and Germany, I believe. And so as the cost has come down, this makes it much more easy to put together schemes that are cost competitive, and in some cases, I believe, cheaper than fossil fuels. So I think it's fantastic that here in New Zealand we've got a generator or a lines company who are looking at a whole range of stuff, from anything from 1 to 2 kilowatt panels on individual houses up to thousands of kilowatts for a sort of large scale pilot scheme. So yeah, I thought that was fantastic news, and it's made me, I mean, the last time I looked at the idea of putting solar panels on my roof, the payback period was going to be, I suspect it was well over a decade.
Yeah.
And the capital involved quite substantial, so kind of took second place to paying the tax bill.
The same for this well project. In the space of a few months, the return on investment has gone from about half a century to just under 10 years.
Yeah, and this is one of the reasons why we've talked about solar power pretty repeatedly, actually, on this program. I really do think that this stuff has got the potential to change the way that we think about electricity. So whilst there's probably always going to be a need for what people call baseload power, which is just a sort of fixed amount of power that's out there that you can tap into when you need it, I think an awful lot of people may well come back to what they call distributed generation, where you can have your own generating, whether it's solar photovoltaic or a windmill or whatever, and use the grid, the national grid, as a sort of battery. So you're connected, but you generate your own power, you sell it back, and then when you need the grid, you can pull power off it. And so you end up with people taking their own generation into their own hands.
Yeah. All this talk of photovoltaic cells, Gareth, has given me an appetite for pretty pictures.
And I have to say, the first picture on this page is an absolute stunner. Now, this is not photovoltaic, this is solar thermal, but it's a picture from National Geographic's Daily News of a solar plant in southern Spain. So those are concentric rings of mirrors, parabolic mirrors, I believe, that focus the sun in onto a furnace at the top of the tower. So the big white star that you can see in the middle. For all of you people who are listening in black and white, I'm afraid you'll have to go and look at the website.
It's the Eye of Sauron.
It is. It's an absolutely stunning picture. And of course, this is the other side of the solar energy coin. So instead of directly converting the photons that they arrive into electrons in a cell, what you're doing is you're harvesting the heat in the sun's rays, focusing it in on a boiler effectively, and then using the heat that's generated to turn a turbine and make electricity. And with various clever forms of engineering, you can heat a liquid that you can then store overnight and use to generate when the sun isn't shining. And of course, southern Spain is a particularly sunny part of Europe, actually beginning to turn into a desert. So, as the climate has been changing in southern Spain, so these plants have probably been doing really rather well. But beautiful pictures on the National Geographic site, as you might expect. And I will, they're very well worth looking at.
They're very, very nice. Very pretty stuff. Okay, on to the next topic. Electric jeepneys. Jeepneys? To reduce pollution in the Philippines. Jeepneys?
Absolutely. Yeah, jeepneys. Jeepneys are the little sort of micro buses that they have in the Philippines, particularly in Manila. And they're traditionally sort of petrol or diesel driven, and they contribute quite a lot to the sort of pollution in the city. They've started to make them electric, so an e-jeepney, and an environmentally friendly of this thing. They're called jeepneys because after the Second World War, basically they were made from US military jeeps that had been left over. And they're sort of seeing this in the Philippines as the beginnings of a changeover to environmentally friendly transport throughout Southeast Asia. So in Singapore, for instance, which is a bit more high tech possibly than many of the other cities in Asia, they're looking at hydrogen-powered public buses. Thailand is looking at electric tuk-tuks. I don't know if you've been to Bangkok, but the tuk-tuks are a fixture. They're those little tricycles with sort of very noisy motors that little guy on the front pulls around two people in the back of his tuk-tuk. These are now going to go electric, which I suspect may be disastrous for people who jaywalk in Bangkok.
You just wouldn't be able to hear them at all, would you?
Yeah, you wouldn't be able to hear them coming. You might get run over. But I thought it was an interesting story just to show that, yes, we can generate this electricity in these solar photovoltaics or solar thermal stations, but the key to it is then using that electricity to move us around and cut pollution and generally transform the way that we use our energy.
These jeepneys kind of remind me of either like sort of glorified golf carts or those Flintstones vehicles where you just expect everyone on board to start running.
Yeah, but they're all sort of wonderfully decorated.
Yeah.
I mean, they're a bit like those the sort of lorries and buses that you see in India and Pakistan and Afghanistan. The amazing decorations all over them. I think there's a little bit of that going on in the Philippines as well.
Very cool. Finally, we're taking bringing a story back to New Zealand, a bit of a success story locally in New Zealand, Lanzatech.
Yeah, absolutely. Now, Lanzatech are an extremely interesting company. They are a biofuel organisation born and bred in New Zealand, and they've just been recognised as a world leader in energy innovation by Bloomberg, and they've been selected as a 2012 New Energy Pioneer. And that's really quite sort of amazing that, first of all, that a New Zealand innovator can get recognised on a global platform like that. But what they're doing is really interesting. They're basically using what they call bioreactors to deal with waste gases as they come out of energy plants or steel plants, and using the bugs they use basically can use these gases as a feedstock to then make chemicals that they can use to turn into things like petroleum. I mean, they're not exactly producing stuff that can go straight into your car, but they can take the products from their bioreactors and then make things that are very, very similar and can be used for powering your car. So it's a much greener way. This is carbon that's already around, and so you're not introducing fossil carbon into the atmosphere. And they've got a very promising technology. They're working with New Zealand Steel, I believe, at the moment, to capture carbon monoxide from the steelmaking process, as they've got a pilot plant running there. So I just thought we ought to have a little shout out for a New Zealand company that's making waves on the global market.
Yeah, Lanzatech. Go Lanzatech. Have they been purchased by overseas, or I think they've been bought out?
I really don't know. I've no doubt somebody from Lanzatech will be in touch to tell us, but certainly they were born and bred in New Zealand.
Yeah, they certainly were. Very, very nice. Well, that wraps up the solutions segment, and therefore the end of this climate show, episode number 25. Lovely having everyone along for the journey, whether it be listening to it or watching it. And of course, our guests as well, Jason Box, will be following. He'll no doubt be keeping us up to date as well with what he's been doing. And John Cook at Skeptical Science. And of course, lovely to see you again, Gareth, as well.
Well, if you can see me through this haze that Skype's presenting to us at the moment. But anyway, I just wanted to say that I think it's probably safe to say that compared with the nightmare that we went through to get the show out last time, 3 weeks ago,
much smoother.
When we were recording in out of sequence with all sorts of technology. Oh dear, this was all recorded basically in one long go. So unedited. Well, it will be edited, won't it, Glenn? And you'll be getting it out very soon, won't you?
Yes. And we should go before the internet's completely give out on us. As all the kids come home and start downloading everything. Now that school's out for today, that's exactly what's going on. That's what happens in New Zealand. The school's out, kids get on the internet, and it all packs up.
turns to custard, which is a bit like my partner's PC, which I gather has just turned to custard in the other office. So I may need to go and deal with that. So anyway, Glenn, thank you for a great show. I really enjoyed talking to Jason and John, and look forward to speaking to you again in a couple of weeks.
See you next time. See ya.
What good is a drop in the ocean? What good